Hi, everybody. Welcome to Math with ACE. We are focusing on statistics today. We're going to be working with the normal distribution and specifically using technology and Stapplet to calculate with some examples. And I want to talk through how you read a problem and how you know what to do with it. Now, because we are talking about the normal distribution, when you go to stapplet.com, under probability, you're going to hit normal distributions. And then if you are dealing with a standard normal distribution, if they're told it's a standard normal distribution, that implies that your mean is 0 and your standard deviation is 1. So be on the lookout for that. If you're asked to calculate a probability, then you want to calculate the area under a normal curve. If you're asked to find a value, then you would want to select calculate a value. So we want to approach a problem like that. The first example that we have here, we actually don't need to use technology for at all. It's about notation. If the probability of x is less than x is equal to 0.0228, what is the probability that x is greater than x? What this is saying is, if at some value, the probability of being less than that is 0.0228, what is the probability of being more than that? Well, these two are complementary. One is to the left and one is to the right, and together those two make one whole. So the way that I can calculate that is I can say 1 minus the probability that we're given. And this is given as a decimal, so I can leave it as a decimal. And if I do 1 minus 0.0228, I get 0.9772. So if the probability to the left is 2.28%, the probability to the right is 97.72%. So the notation matters. I know some students struggle with, how do you know whether it's less than or if it's greater than? So what helps me is remember that in our language, we read from left to right. So as you go, as you're reading it from left to right, do you see the point first or do you see the open first? If you see the point first, that means you're dealing with less than. If you see the openness first, that means you're dealing with greater than. And also these come from a number line. So the one on the left is a number line to the left, to the right, goes this way, so less than and greater than. Okay, final exam scores in a statistics class were normally distributed. It's important that we're told this so we know which calculator we can use, with a mean of 63 and a standard deviation of 5. Great. I'm entering a mean of 63 and standard deviation of 5. I'm going to plot the distribution. And the great thing about Stapplet is that it fills in the values for you that you would use for the empirical rule. It gives you 1, 2, 3 standard deviations to the left and to the right. I'm asked to find the probability that a randomly selected student scored more than 65 on the exam. So I'm told more than, and I'm told a number. And probability means calculating the area under the curve. So I have calculated an area under the curve, that's good, but I don't want between two values, I just want more than. Well, is more to the right or to the left? Let's say I'm not sure and I say to the left, and then I put in 65. It's going to shade for me. And if you notice the shading, those are not values that are more than 65. So what I want to do is I actually want to go to the right of the value 65. And then that tells me the probability that x is more than 65 is equal to 0.3446, or Stapplet gives it to us as a percent, which is 34.46%. And that's at the very bottom of the screen right next to where it says calculate area. And the super cool thing that Stapplet does is it actually calculates the z-score for you as well. Okay, now I want to find the probability that a randomly selected student scored less than 85. So if we know that to the right is more, then to the left is less. So left is less. Calculating that area, well, 85, less than that is actually 100%. Why? Well, if the average is only 63, 85 is off the charts. Everybody is less than 85. So that's awesome. This person did great. 100% is below, roughly. So the probability that x is less than 85 is equal to 1, which is the same thing as 100%. Now we're asked to find the 90th percentile. That is, find the score that has the 90% of the scores below it. So finding the 90th percentile, we're not being asked for the probability because they're telling us your probability needs to be 0.9. What they're saying is we want the value that is 0.9. So instead of calculating the area, we actually want to calculate the value. Now, our options are left, right, or central. I'm going to enter 0.9, and that is the 90th percentile is less. This is good. Percentiles are always the value and less than. You can do a greater than, but that's not when we're interpreting a percentile. Percentile is always dealing with to the left of the value. So the 90th percentile in this situation is a score of 69.408. If the person was not, if it was supposed to be a whole number score, then this would have been 69. It just depends on what the how the teacher graded the exam. If the teacher graded with decimals, this could be valued. This could be valid, or it could be just a score of 69. It just depends on how the teacher grades. The 70th percentile means that I then need to say 0.7, calculate. So that is a score of 65.622, or rounded to 65. Actually, I would say 66. I'd use decimals sometimes depending on if I'm grading a test that has like out of 13 or something. I'll round and I'll do maybe to the 10th, but I don't think I'd do something to the 1000th. So this to me probably needs to be rounded. Okay, let's do another question. A personal computer is used for office work at home, research, and communication, personal finances, education, entertainment, social networking, and a myriad of other things. That means a lot of things. Okay, great. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. So we have to like dissect this problem. We have to get through this whole problem just to find the fact that it said, hey, average is 2 hours. So in here, my average is 2. And then it says, assume that the times are normally distributed. Great, this means I can use a normal calculator. And the standard deviation for the times is half an hour. Okay, so how am I going to enter that? Am I going to enter 30 or am I going to enter 0.5? I entered 2, which was in hours. So what I need to enter my standard deviation is also hours. So this is half an hour, which is 0.5. Now my distribution changes. The number line fills in with the values for the empirical rule. I want to find the probability, this means area, that a household personal computer is used for entertainment between. Okay, so let's go to calculate an area. And my options are between, left, right, or outside. This question says between, so that's going to guide us to use between. Let's do outside just for fun. Outside also has 2 boxes, and I'm able to input 1.8 and 2.75, but when I calculate the area, I see, no, that's not between. That's the complement of what I want. So actually what I want is between the 2 values. And now I see, okay, I'm between, I'm good. And it tells me the z-scores of the boundaries. That's about negative 0.4 to the left and 1.5 to the right of the mean. And so the probability of being 1.8 less than x is less than 2.75 using correct notation is 0.5886, which is equal to 58.86%. Find the maximum number of hours. So now I'm not asked for a probability, I'm asked for hours, which is a value. So I need to change to calculate a value. To find the maximum number of hours per day that the bottom quartile of households use a personal computer for entertainment. What is a bottom quartile? So when I'm looking at quartiles, the way that I remember it, quartiles to me sound like quarter. And a quarter, there's 4 quarters in a dollar. So there's 4 quartiles in your distribution. And each quarter in your dollar is 25 cents, 50 cents, 75 cents, and 100 or a dollar. So 25 cents is the lowest one. So this is saying find the 25th percentile. If you're asked to find the interquartile range, that means find the 25th and the 75th and in between those 2. So when you're looking at quartiles, remember when you did descriptive statistics, quartile 0.25, 0.5, 0.75, depending on which one you're dealing with. So find the maximum number of hours at the bottom quartile. So I want to find an area of 0.25 and it's bottom, and this is the highest number. So this is the value that I want, and the value is 1.663 hours. So the maximum number of hours per day that the bottom quartile uses Why did I type it out rather than just saying 1.633? I think context is important. If I just said 1.633 and didn't tell you anything, what does that mean? What is 1.633? It's a naked number. It doesn't help us. So the maximum number of hours per day that the bottom quartile of household users use a personal computer is 1.633. And I should probably say hours. I mean, I said it before, but it's better information. All right, let's do one more. See if you can pause the video, read this, and determine where should I be in the normal curve. A citrus farmer who grows mandarin oranges finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution, great, using the right calculator, with a mean of 5.85 centimeters and a standard deviation of 0.24 centimeters. I can plot, now my numbers change. Find the probability, I'm not in the right place yet, find the probability, which is area, that a randomly selected mandarin orange from this farm has a diameter larger than 6. So right now I have 2 boxes, which means I'm not in the right place. And I don't want outside a region. So is it left or is it right? Which way is larger? Larger to the right. So to the right of 6, that is 26.6%. So the probability that the mandarin orange is larger than 6 centimeters is equal to 0.266, which is also 26.6%. All right. Ooh. The middle 20% of oranges have diameters. All right, so we are already given the percentage. So I'm not trying to calculate a percent. I need to calculate the values based on the percent. So I need to change back to calculate a value. And I have 2 blanks and only 1 box here. So want the 20%. But if I just did this, I only get 1 number because it's not between. So remember, I need central in this situation. So central tells me it's between the 2 values of 5.789 and 5.911. So the middle 20% of mandarin oranges from this farm have diameters between 5.789 and 5.911 centimeters. Okay, what about the last one? Find the 90th percentile. We're in the right area, but we're not using the right function. 90th percentile does not correspond to a confidence interval. 90th percentile means from that down. So I need to the left. And everything to the left of the 90th percentile has a value of, is the maximum of that is 6.158 centimeters. So the 90th percentile, or the diameters of mandarin oranges, is 6.158 centimeters. That means that 90% of these mandarin oranges have a diameter less than 6.158 centimeters. Okay. Now, you can use a Texas Instrument calculator to do this. You could use StatCrunch. You can use Excel. There's a whole lot. You could make z-scores and use charts. There's a whole lot of options out there for calculations. I just think that this applet is a free resource, and it's a really good intuitive resource, and that's why I prefer it. Thanks for watching, and have a great day, y'all.